Cool. Thanks very much. Thanks for having me, everyone. Just before I get started, if you like the talk that I'm talking about and it's a subject that interests you, obviously I'm here all day and I'll be here for drinks in the evening, but also there's a bunch of hidden slides that won't be shown today. So, if it interests you, download the slide deck. There's like double the number of slides. Just a lot of them are hidden. Which way's forwards? That way. Cool. Yeah, so that's me, James Bensley. I've been sort of designing and building and supporting networks and stuff for over 10 years now. I just highlighted the word decommissioning though, because it's something that I come across in designs a lot. People don't put much thought into how this network is going to get broken down. You build a network and hopefully it's going to do that thing that you need for the next 10 years, but actually in 3 years your company goes bust, the project's closed down, you build a better network, whatever, and you never labeled the interfaces properly, the guys that built it have moved on, blah, blah, blah. I've had people come and say things to me like, I've been building networks since before you were born. Well, I can tell you, until you've migrated from a network with no documentation, that is out of vendor support and stuff, you really haven't had a tough time. So I'm starting to get the first few greys, and and I've broken some things, and I've really built some horrible networks. So I know definitely what a bad design looks like. So I think sort of logically, I've got a not too bad idea of what a good one should look like. So the talk today is not very specifically, how do I do that exact technical thing? Like, so how do I, produce a really good layer 3 VPN? That's some very specific technical problem that you have that you need to solve. The talk is more generally agnostic for whatever you're building. If it's just a single DSL line with a CP on the end, or like a 15,000 site WAN, the same rules kind of roughly apply. So that's what we're going for here. One of the key things that I've learned from experience over the years is that it's not about technically what do you need to do, it's about identifying what the sort of correct decisions are. So it's not all technical, and that's going to feature quite a lot in this talk. Not everything you do is technical. There's a huge part of our jobs that are non-technical, like organising the project and getting stuff delivered on time and finding the right people. All of that takes a lot of headspace and a lot of time and effort and money. So it's about actually just asking the right questions. What do you need to do to make this project, it's a network, work? Because then when you fail to meet expectations, that's worse than a broken network. If I have to deliver a network and the deadline's tomorrow and I'm 85% done, but that 85% works, people are more happy with that than me. If I delay by 3 weeks in order, because say no, nothing's working. The expectation when it's due tomorrow. So it's better to meet people's expectations. That's more important than something being broken. Broken things can be fixed once you've kind of let somebody down. You've let them down. You'll know about it. And on the last point, so we just had a talk about automation, which was a really good talk. But I have a bit of a personal gripe against automation, which is that a lot of people I know are not that great at thinking through their designs or their configuration stuff. And as someone who designs networks, automation is like a nemesis of me, because I see a lot of people who just have like this machine gun with which they can spray really bad config out across the production network very, very quickly. I'm like, if we just planned this out a bit better, we wouldn't, we possibly wouldn't need to be doing this in the first place. A key thing about design, that is my day job. I'm a network designer, is to identify this stuff while it's still in design phase. Answer all those questions as early on in your project as you can, as possible, and then by the time you start rolling it out, you don't get halfway through, have to stop, bring it all back in and do it again. You just want to push it out and be done. I'm going to share some of my real-life experiences. Like I said, there's a bunch more that are hidden that perhaps should be hidden, so that they're not mentioned here in public, but you can view them for yourself in the rest of the slide deck. And it's something that I think I would like to encourage more people to talk about. It's the kind of non-technical aspect of this industry. We have lots of talks at all these conferences about very, very technical things, which as a technical person I find very interesting. But my day job is actually a network design engineer. That's my actual job title and my function within the company I work for. But 50% of my job, at least, is not technical. It's asking these guys, when are we going to get this delivered? Who's going to pay for that? Who can do this install? So on and so forth. One of the biggest problems we have, I would say, in this industry is complexity. So what happens a lot is people do really complicated things, and they love to do complicated things, especially engineers. So I've put there, engineering is typically associated with complexity. Over-engineering is by far one of the biggest problems that I have in the day-to-day. environment, some support issue gets escalated up to me, and I have to log onto this system and try and debug it, and it's superbly complicated. It takes me days to unravel how this thing works, and I'm just thinking, why was this even deployed in the first place? It could have been much simpler. And there's a bunch of quotes by people we generally respect. KISS is also the famous acronym that we try and stamp on everything we do. The simpler it is, the easier it is to support. This is the big issue in our industry. But to highlight the fact that also the technical aspects aren't always the toughest part of our jobs. So I've worked in teams with mixed abilities. So if you ever worked in a team, we have like the most junior engineers and the most senior engineers in the same team, and then you share an on-call rota. That is tricky, where you have, which is how life goes in smaller companies, right? You have an on-call call come in, and it's a very complicated issue, and it just happens to come in when the most junior guy's on call, or it's a very trivial issue, and it just happens to come in, when the most senior guy's on call, and he's thinking, why am I getting woken up for this? So mixed technical abilities within your scheme your team is very difficult to manage. Mixed skill sets. I've worked in teams where you've got like server guys, application guys, voice guys, all in the same team. Again, sharing like an on-call rota. That's very tricky to manage. When you design a solution, you have to think about who's going to get the on-call call. If the server guy gets a call about a switch stack that is flapping, I don't think he's going to be much help to us. Mixed availabilities, if like me, you've worked like across time zones, this is also very difficult. And again, you need to think about this in your designs, especially from the support perspective. What's the time zone that you put on all your syslog messages? Do you put the country that the device sits in? Do you use UTC time? Do you actually have both? And I had a lot of arguments with people for and against and all this kind of thing. It seems like some sort of religious issue. And the other thing is mixed communicative, as in, so not programming, mixed spoken and written languages. I obviously am English, speak English, but I've worked with many people, who, when English is their second or third or fourth language, I can only speak one, so I'm gobsmacked at that. And, I say something, and then I say, you repeat it back, and they say it back. Okay, great, you've got it. They write it down, something else. And it's not because it's not malicious or anything, it's just people just communicate in different ways. So again, you need to factor all that into your design. Not just have I documented all the links and the IPs and the routers, like does it actually clearly explain what they do, what the function is, who will be using it and so on, in a way that anyone can understand? And just finally, I would just say on the whole, over complexity thing is that the job, in my opinion, the job of an engineer or an architect, designer, technician, whatever you are, is to be multifaceted and be pragmatic. So you don't just focus on those really complex things, right? The main part of the job for me is you translate between some sort of business requirement or customer demand and reasonable technical methods. So something that, there's some project requirement, you need to deliver on that requirement, but you can't just think up the coolest thing ever that will do it, right? Someone has to support it. You're going to leave one day or get hit by a bus. Someone else is going to have to pick this up. Even you'll have to pick it up 12 months from now when you've forgotten how it works. So the engineering is really about trade-offs. So if we look at this spider diagram, for example, from like me on an average day, for example, if I'm really tired, then I can just increase my coffee breaks or just drink more coffee. Great. If my tiredness comes down, my coffee intake goes way up. So that should be the problem solved, right? But then what actually happens is the more coffee I drink, the more I have to go to the toilet. My anxiety starts to go up, and my productivity hasn't really come up that much. So those are like all the things that you balance in your day-to-day life, even at the weekends. But so let's look at this example question, right? So let's say, just one tiny aspect of your network is which CPU we're going to use for DSL connections, right? Because you sell DSL and you sell fiber and you sell long distance, wireless. You sell everything. So just one of those connectivity types, you need a CPE for it. Let's say it's going to be some DSL connection. So just the CPU that you're going to use, you have to answer all these questions, right? How much is it going to cost? Because the finance man just needs to know that this project is going to come in within budget. How quickly will the vendor deliver them? Because the project managers want to know that we're going to hit the target for this project. What are the SLAs from the vendor? Is it going to be next business day or next working day? Is it 4-hour on-site replacement? Because the account manager has to go and stand in front of the customer and be thankful for what he receives when it all goes wrong. How complex are these devices to use? Someone has to support them, so the support teams want to know how complex are they to use. what functionality is in the devices, right? The customer or the project, it must be a requirement that brought you to where you are now. Does it fulfill all the functions that you have to do? If you have any compliance restraints, so like I used to work on a PSN network, for example, we used to have to think about these kind of things. You know, someone's going to be auditing that, so do these devices comply with any auditing restrictions? And is it standardized within your company? You know, there's an implementation team who has to put these devices in the field. You know, is it something that will be brand new to them, or is it just a different CPE from a vendor you already used? So there's like all these complicated things that you have to balance, and this is just one tiny piece of the whole project that you're working on. So let's go through some examples. Basically, this is some of the examples that I've seen, you know, so far. So I'd say, you know, do some do's and don'ts, right? Do design a solution that satisfies the problem definition. That's an obvious one. You've got to do. There's some ask that's brought you to where you are. So, but don't design what you think would be like really cool, which is what I see a lot of engineers doing. They get really stuck up in this sort of, you know, new technologies, bleeding edge technologies. You know, I'm a techie. I want to be doing that as well, but actually, not everyone does, and not everyone wants to pay for that. So keep in mind the budgetary requirements, but don't just search for the cheapest possible solution. A lot of engineers I see get worried about this concept of having a budget, and you know, someone's got to sign off on this, and you know, you'll get chastised if you go over or anything like that. So you've got to kind of balance those aspects of requirements and costs and stuff. So this is an example, right? So let's imagine there's this task. I need 15 gigs of connectivity from point A to point B. And if I need 15 gigs, and my two options are, let's say, 2 10 gig links, which is a bit boring, or a 100 gig link, which is really cool and exciting. Both of those, on paper, satisfy that requirement. And if we look at the 10 gig option, for example, when we exceed 15 or 20 gigs, we can just easily add another 10 gig link. You know, we can just keep adding more 10 gig links, and that's quite cost effective. And you know, lags or ECMPs, that's a known evil. We can deal with that. That's known to operations, not a major issue. If we look at the 100 gigs, though, straight off the bat, we've got 85% wasted capacity. You know, even if you get a really good deal, how many spare 100 gig ports do you have? You know, the other thing is, on the plus side, though, that operationally it's a bit simpler. One link is always easier than two, and as you upgrade, say, the n by 10, you go from 2 by 10, 3 by 10, 4 by 10, 100 gig link, still just one link. That's much simpler. So, you know, just looking at those on face value, it's not actually clear to me which one of those is better. You know, I think, this is the point I'm trying to highlight, that then you actually need to go back and clarify, well, what is the requirement? You know, when will we need the next capacity upgrade? Is there something else we can use the spare capacity on that 100 gig link for? How long will this be required for? So on and so forth. So you have to kind of get more information and clarify those requirements, and then you can balance out that decision a bit better. Looking at the same thing just on a cost perspective, 10 gig ports are very cheap, optics are cheap. If you're getting this from a third party, 10 gig rental is cheap, great. But actually these days, 100 gig ports, you know, especially if you use white box equipment, 100 gigs very cheap. Optics are pretty cheap, not quite as cheap, but they're pretty cheap. Or if you get it from a third party, you know, 100 gig wavelength, again, they're coming down in price. They're not eye-wateringly expensive, let's say, as they used to be. So again, you can't just look at the cost purely and go, yeah, this is a clear-cut decision. You have to go back, gather the requirements, bring them in, work out what's needed, until one of these kind of comes forward as the clearer way. So I've put there, do clarify unambiguously what the project requirements are. If it's not clear to you, then you've got those two options and you're not sure which one you're going to go for. And then at some point in the future, a requirement will come forward and you'll realise the choice you made was wrong and you're in a lot of trouble. And try and work out if the requirements can be broken down, because it takes more time to implement more features. People care more about time, though, than they do features. So what are we actually delivering? Scoping out what the deliverables are, there's a balance that you need to strike there, right? So if we look at the first paragraph, so if we need to provide an internet connection at location XYZ, and if I say that the deliverable is going to be, we'll provide a connection using 4 twisted pair copper cables, with each pair signaling at a frequency of 125 megahertz using 5-level encoding scheme to achieve a layer 1 bit rate of 1.25 gigabits, probably should be gigabaud, with a 2.5 volt peak average differential per twisted copper pair to maintain DC balance. That's probably a little bit too specific. Possibly could have gone back a step there, but if you just say it'll be a 1 gig handover, that is also not super clear. So you have to strike a balance and go, it will be a 1000 base T Ethernet handover interface using an RJ45 terminated Cat5e cable. I think 99% of engineers get that last statement. That's clear how that will be done. So documentation and support, I mentioned this a bit already, think about how you'll document a solution and how easily you can explain it and how will others understand it. I think if you can't explain it, then no one else is going to understand it. So that's kind of a good point, is whatever you build, certainly a lot of places I've worked in, whenever you build something, a network or a system, you sit down with the guys who are going to support it and you do a full run through, even if it takes all day or several days, and if they come out and they don't understand it, you need to go back and start again, or you need to remove something from your design, it's too complicated. Think about how that on-call engineer is going to troubleshoot it at 3 a.m. What documents will be available? So will there be a HLA, HLD, LLD? Some people just have config templates, wiki articles, knowledge base articles. Some people have troubleshooting cheat sheets, just literally run this command, was the output a 1? If it is, do this, if not, do that, almost like a flow diagram. Break it right down so when you're so tired, you can still troubleshoot it. So this is, again, thinking about documentation and support. So, you can design anything that you want to be deployed, but it doesn't mean that the operational team can actually support it. And there's also some things that operations can support, but that's not necessarily what you're designing. You need to find what you can design and what they can support, and the overlap of that Venn diagram. Only that is what should actually go into your production network, and nothing else, hopefully. But try to be so specific in your documentation that you don't need configuration examples. Who here has ever put config into a Word document?
Only under duress?
Yeah.
I understand config output.
Yeah. I really hate it, and I really hate it, and I do it all the time. I feel like they're the sort of code comments of networking engineering, like your code was not clean enough or easy enough to understand, so you had to put a comment in. And I find it the same with design documents, even the ones that I write. It's like this design. I should have spelled it out for you so clearly. There's no need for me to provide a config example. For some reason, I have. Tomorrow we're going to switch vendor, so all the config in that Word document needs to go. Word documents are not a great place for storing config, by the way. So I don't have to rewrite this 250-page document. The design should be so clear I can just configure that new vendor tomorrow and get the same effect. And have a little think about who I touched on this earlier, mixing disciplines. I said I've worked in teams where you've got server guys and network guys in the same team. So again, it may be that you have to break that documentation out into sort of less complex to more complex versions of the same document as well, so that different teams can actually be involved in the troubleshooting. Monitoring. I don't know why people don't spend more time on their monitoring. I've seen some horrendous monitoring deployments in my time. I know people who are polling their network once every 15 minutes. I think once every 5 minutes is slow, right? A real example that happened to me was we had an RFP from a customer, and what I would consider quite a normal requirement is they said that if a link goes down in the network device must detect and fail over within 1 second. Fast free route's been around for many years, it's quite stable, there's nothing too unusual about that. The requirement from the customers, though, is that our NMS must detect and prove that we rerouted that traffic in 1 second. Now, that is very difficult to do. A lot of that stuff isn't available via standard SNMP polling. Not all of it is available via traps, so it's not, the immediate knee-jerk reaction was, can we just poll more than once a second? Of course we can't, no. So you have to think about some other design, some other way to tackle that problem, Upgrades and failures. This is really tricky. It's really tricky to think about upgrades. When you put something into production and you think, right, how is this going to cover our requirements for the next 3 years, 5 years, 10 years, whatever, that's a really tricky thing to do. I've been in many, many meetings. People have no idea what's happening beyond 3 to 5 years. 2 years is sometimes a push. So trying to design your network for longevity is really tough. And the way I do it is I think about the OSI stack. So when we put stuff, physical stuff, like so if we put fibre in the ground, we expect to be putting that in for multiple decades. No one's putting fibre in the ground and then pulling it up 12 months later. And as you go up the OSI model, the longevity of that stuff kind of comes down. People put switches in a switching closet and they leave them there for 10 years, so that's fine. People put routers in, and as traffic increases at the P&T edge, we'll swap them out in 5 years' time. people put firewalls in, and within 24 to 36 months, the TCAM's full and they can't have any more ACLs. So this, it's unique to your scenario, but you need to think about, if you have no. So I've been in many scenarios where you have nothing coming back from the business. They can't tell you what's going to happen next week. Then you have to think about something a bit more logical. Where does it sit in the OSI stack, for example? Consider the different failure scenarios that can happen. Obviously, people think about things like loss of power, loss of connectivity. So we put two power feeds in, or we put battery backups in, or we have two routers. Those are kind of what I would call logical and expected failures, if that makes sense. Or they're all the things that you can walk through and build a nice little dependency tree and work it out. But you don't limit your consideration just to that logical sort of cascading failure tree. I've put, if you design it, they will use it. And I'll show you what I mean in a minute. But essentially, any command that has not been blocked by TACACS will be run at some point. I can guarantee it. Any IP address that has not been filtered by a prefix list on your network will be advertised at some point. I can guarantee it. So you need to think about, and it's not always by accident, you need to think about how someone's going to fat finger it and type 8/8 instead of /28. So one example that, this happened to me. It was an extremely bad day, I can guarantee you that, which was, in this scenario, we had two data centers. We've got two routers in each data center. All services are dual homed to both routers in both data centers. Brilliant. This is loads of redundancy, more than you can shake a stick at. What could possibly go wrong? I can tell you what can go wrong. Is that even though we had dual power supplies to all the racks, the routers have got dual routing engines, dual line cards. Obviously, there's two routers as well. There's two DCs, same services across two DCs. All those routers are the same make and model and software version. And one day, one of our customers was sending some traffic, a very specific kind of traffic that actually caused a wedge on the ASIC, on the line card in the router. Line card reboots. This in turn triggers a router reboot. The first route is down. So everything fails over to router 2. 30 seconds later, that route is down. The customer's still sending the same traffic. Everything's flipped over. This is within 1 minute. Everything's flipped over to DC2. The customer's still sending the same traffic. The third route is down. Everything's fallen over to the last router, and whatever that customer was doing, they gave up. And so by hook or by crook, the last of those four routers stood up, but it was now so heavily congested it might as well have been down. So this sort of super resilient deployment, just didn't even think of the most basic thing that actually they would all have the same software bug at the same time. So that's an example of one of those sort of expected failures that you can think through with a kind of dependency tree. But these sort of unexpected failures, they're really difficult to think up. So in this example, we deployed remotely triggered black hole routing, which a lot of people use in their networks, as a kind of last resort. If you don't have any anti-DDoS stuff, or it's no good for whatever reason, people will use kind of BGP signaled black holing. So, a very real scenario that happens to me is, we have no prefix length validation. So someone wants to black hole 10.10.10.0/28, and they fat finger it and put /8 on the end. So they just drop 10/8 inside our network. That was a bad day. Prefix validation. Equally, someone wants to black hole 10.10.10.0/28, and they fat finger it and they put 1.10.10.0. That's not a prefix that my network announces or receives, so there's no reason for me to be black holing that. If you say you're doing destination, black holing, and that's not one of your downstream customers, and they're being DOSed, there's no reason for you to be able to black hole that prefix. That also happens. Prefix purpose as well. People seem to allow, so not just is it like your customer or your peer or anything like that, people also don't think about their internal prefixes. So, we had a scenario where basically our internal voice gateways, which are obviously not announced to any customers, any transit providers, any peers, so no one has access to them, they're not routable by anyone except us, that prefix can also be black holed, taking down all the phones. So those are what I would call unexpected failures. They're much more difficult to think through. There's kind of a usability feature of your design. I went through quite quickly, so that's it. Hopefully that sort of made sense. And any questions?
Any questions for James?
Have you found a way of designing out some of the human error of things like naming of devices. I'm thinking of the situation I've had where the boss asked us to deal with server number 69 and not number 96, which just happened to have our biggest customer on it. And you get examples like that throughout, and it's particularly problematic when something breaks in the middle of the night and you're on call, and you've got all of these routers that are just the same thing with a number and changing. Have you found any good way of dealing with that through design?
Yeah, okay, yes and no. Two parts, if it's okay. The first part, because I think that you can kind of split that problem into two things. One is kind of human error in terms of things like typos. This happens all the time. It's extremely difficult to deal with. And my honest answer is that I think we'll never solve human error. That will just never go away. It's just about how much of it can we actually, how much of it can we limit. And there's a few things that I've seen at different places over the years that I think help with that. One is obviously education. You try and educate your people as best you can. Obviously things like peer reviews and double checking, that kind of stuff. That's all what I call standard stuff. That doesn't happen at 3 o'clock in the morning when everything's burning on fire. But I have, for example, worked at a place where we have more than one person on call. And so if everything's an absolute meltdown, you call the second person. So you've always got a second set of eyes on things. I've also seen lots of what I would call tricks. So people do things like, when you log onto the production network, the terminal's bright red. If you're logging onto the server for this customer, it's blue, this customer's green, so you can see immediately you're on the wrong server. They do bespoke banners, login banners, all this kind of stuff. There are kind of technical things that you can do, but I think they're tricks. I think the human error thing is never going away. So obviously the previous talk we had, CI/CD kind of automation stuff really helps with that as well. But again, there's nothing to stop me just misreading that Git merge and approving it, and there was a typo in there, and so on and so forth. It's just, I think, using technical factors to limit the potential impact, but also just education. You just have to teach people to I know people who get really stressed when they're on call. You teach people just to be calm, stop, write the command on the command line, stop, read it back, read it again, then you can press enter. It's strike a balance.
Before you ask the question, please.
Martin Saunders from Highlight. Do you have any design tips on how you help the poor people that have to try and reconcile the incoming invoices and outgoing revenue for these wonderful big networks that we've built, so you make sure you're not carrying costs for circuits that you realise haven't been plugged into anything for years and years?
It's a similar answer to the previous question. I'm not sure that's ever going to go away because everywhere I've worked has got that problem. There's two things. On paper, it's a technically easily solvable problem because, for example, so a kind of rudimentary example would be in my day job we have quite a complicated interface naming description standard, and in there it describes if it should be live or not, who it belongs to, and so on and so forth. So we can kind of scrape that information from the monitoring system. The monitoring system scrapes the interface descriptions. We can then scrape the monitoring system to see there's an interface up. Actually, this should be gone. This customer's gone. But I think there's a more fundamental issue there, which is about OSS and BSS data. Having your data. Those. I obviously don't know your particular scenario, but a previous company I worked at kind of had a similar problem where we had lots of stuff floating around that we're still being billed for, and we're not billing customers for, and this kind of thing. And a huge part of that was a disconnect between OSS and BSS. And so that was more like an internal data thing. We needed to look at merging that data and bringing the two together. And so that's kind of a much more fundamental business change rather than a design change.
One more question.
On the subject of human error, obviously, like you say, there's sort of training and good documentation and various things that you can use to try and reduce that so people are well practiced. Whether that's doing DR exercises and things like that. But are there any kind of specific tools or practices that you've used? I mean, I know that, for example, Pythian, they do database consultancy stuff, they have a thing they call the FIT ASO, which is like focus, identify, type. They kind of make you little sticky note checklists that you can use and stuff. And do you think that kind of thing is worthwhile, or is it the sort of thing that goes out the window when you're answering a page?
No, I think it is worthwhile. Obviously, when you get, it also depends on the company culture, because I've worked at some places, for example, where if you're having a core meltdown in the middle of the day, so actually everyone you need is there. I've had change managers screaming down at me saying, "You cannot touch a thing. We'll bring this network back online until I've approved it." So it really highly depends on the company, I think. But yeah, in general, I think those things do help, though. So in a previous company I worked at, we wrote out all those checklists, like check this, do that. And it was things like, open a second terminal, have a live log running in that second terminal, work in the first terminal, so that you can see the impact of your actions straight away in another terminal on another screen. So there was tips like that to kind of make the person aware of what their actions were doing, at 3 o'clock in the morning. That comes in a myriad of different forms. But generally, I think they work. Like the companies that I've worked at, we've had good success. Making checklists and stuff. Yeah.
Great. Thanks.
Thanks.
James.
Cool. Thanks. Cheers.